This is Professor Antonio S. Marahas, and this is Advanced Digital Technique. Okay, so we go now to 4-variable map. Okay, so the first rule, 8 adjacent cells yields a single variable. Rule number 2, 4 adjacent cells yields a 2-variable term. Rule number 3, 2 adjacent cells yields a 3-variable term. And 4, a single cell which cannot be combined yields a 4-variable term. So we have here a truth table again. The table was taken based on a particular problem. So later on, we will have a sample problem. So, how many cells do we need in order to satisfy a 4-variable map? So, you have 2 to the 4 is equal to 16. So, we need 16 cells. Okay? So, we draw the map. And we need 16 cells. Okay, so that will be our map equivalent. Okay, then all we have to do now is to determine the value here of your cells. So you have A, B. You have, let's say, we obtain the, we call it the product term of the map. So you have A is 0, B is 0, C is 0, and D is 0. So you have A bar, B bar, C bar, D bar. Then you have here A bar, B, C bar, D bar. Then you have A, B, C bar, D bar. A, B bar, C bar, D bar. Then you have A bar, B bar, C bar, D. And then you have A bar, B, C bar, D. Then you have A, B, C bar, D. Then you have A, B bar, C bar, D. And then you have A bar, B bar. Then you have C, D. Then you have A bar, B, C, D. Then you have A, B, C, D. Then you have A, B bar, C, D. And then here you have A bar, B bar, C, D bar. Then you have A bar, B, C, D bar. And then you have A, B, C, D bar. Then A, B bar, C, D bar. Okay? So this will be our product or sum of product expression or map equivalent. Okay? So, if you notice that in this particular cells, these 8 cells here, the common is A bar. So this belongs to A bar. The 8 cells belongs to A bar. And this one here, another 8 cells, the common is A. So this belongs to A. And then for B, this cells here at the middle, 8 cells, the common is B. Okay. And then on this side, B bar. Then here, the common here is C bar. And then here, the common is C. Okay? Then here, the middle, the side middle, the common here is D. Okay? So therefore, here you have D bar and D bar. Okay? So this one here belongs to B bar, and these 8 adjacent cells are adjacent together. Again, if you fold it, this part here and this part here will come together and they form as an adjacent cells. Now, this part here and this part here are also under D bar, and they are also adjacent, because again, when you fold it going up, this part here and this part here will go together, and therefore these 4 cells here and these 4 cells here becomes adjacent. Okay? Now, let us find the simplified logical circuit of our table using, of course, the 4 variable map. We know that this one here is A, B, C, D. The values are 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. And this one here belongs to A bar. This 8 cells belongs to A. This 8 cells belongs to B, B bar, and B bar. This one here belongs to C. This one here belongs to C bar. And this one here for D, D bar, and D bar. Okay? Then we locate the value of your X into our map. So you have 0, 0, 0, 0, you have the output is 1. So 0, 0, 0, 0, the output is 1. 0, 0, 0, 1, 0, 0, 0, 1, the output is 1. Then 0, 1, 0, 0, 0, 1, 0, 0, the output is 1. Then 0, 1, 0, 1, 0, 1, 0, 1, the output is 1. And then 0, 1, 1, 0, 0, 1, 1, 0, the output is 1. And then you have 1, 0, 0, 1. You have 1, 0, 0, 1. So the output here is 1. And then 1, 0, 1, 0. So you have here 1, 0, 1, 0. The output is 1. Then you have 1, 1, 0, 0. 1, 1, 0, 0. The output here is 1. Then you have 1, 1, 0, 1. 1, 1, 0, 1. Then 1, 1, 1, 0. 1, 1, 1, 0. And then the last one is 1, 1, 1, 1. 1, 1, 1, 1. So the output there is 1. So again, the grouping will be 16, 8, 4, 2, 1. Okay? So if all of the cells are, if all 16 cells are 1, then that means that X will be equal to 1. Okay? So next is 8 adjacent cells. So wala 16. So we go to 8 adjacent cells. So do we have 8 adjacent cells here? I think there is none, no? Wala po siya 15 adjacent, 14, 13, 12, 11, 10, 9. So only 16, then you go to 8 adjacent cells. Okay? So wala po siya 7 and 6 and 5 adjacent cells. So again, you go to 4. So you have 16, 8, 4, then like 3, 2, and then 1. So there is no 16 adjacent cells. There is no 8 adjacent cells. So we go to 4 adjacent cells. Okay? So what are the adjacent cells here? So this one here is adjacent. Okay? Then, instead of having this one, we go straight. Going here, these are 4 adjacent cells. Okay? And then, this one here, if you notice, is not yet grouped. And this cell here is adjacent to these cells. So we make use of these cells here for the grouping of this particular cell. So that will be our grouping. Okay, and then is there any other 4 adjacent cells? This cell here is not yet grouped, which is adjacent to the cell and adjacent to these 2 cells here. Okay, so you still have 4 adjacent cells since this one here is not yet grouped. Like that. Okay, and then this cell here, the remaining cell, is adjacent to the cell. So no more 4 adjacent cells, so we go to 2. This cell here is adjacent to this one, so we group them as one group. So that will be our grouping. Okay, so what will be our equation? So for this particular group, 4 adjacent cells, this one here and this one, this belongs to what? This is under B. Okay, and then under D bar. Okay, it's under D bar. Okay, so it says here 4 adjacent cells yields a 2 variable term. Okay, that is under B, this one here, and this one is under B, and at the same time it is under D bar, the intersection of B and D bar. How about this one? Okay, this line, 4 adjacent cells in line. So this belongs to, again, this belongs to B bar, B I mean, and then at the same time belongs to A. Okay, or you can say A, B. And then this one here, this line, this belongs to C bar. At the same time belongs to D. Okay, how about this one? The square. This belongs to A bar. And at the same time belongs to C bar. Okay? And then this one here, you have 2 adjacent cells yields a 3 variable term. So you have A, C, and D bar. That is the intersection. This group has is under A, C, and D bar. The intersection of this particular cell is A, C, and D bar. So how many groups do we have? 1, 2, 3, 4, 5. So you have 1, 2, 3, 4, 5 equations. Then we put them together using the sum of product expression. So our equation will be A bar, C bar. Again, this can be in any order. Then you have B, D bar. Then you have AB plus C bar D plus ACD is equal to X. Okay? That will be our simplified logical equation that represents this particular output X. Okay? So if we will draw the logical circuit equivalent, we have 1, 2, 3, 4, 5, and gates. Okay, so let me erase first this area here. Okay, so we draw the logical circuit of this equation. 1, 2, 3, 4, 5, and gates. We have 1, 2, 3, 4, 5, and gates. So you have inputs A bar, C bar. Then you have B, D bar. Then A, B. Then you have C bar, D. Then you have A, C, D. A, C, D bar, I mean. So A, C, D bar. So these AND gates are being ORed together. So you have here an OR gate. So even if you have many inputs here in this particular area, try to make the symbol here for the OR gate as much as possible as big as the AND gate. So if you have many inputs, all you have to do is to extend the input part of your OR gate. Okay, so this will be our logical circuit equivalent, and this will be your X. Okay, so that is our simplified logical circuit.